Hello everyone. In this question, it is given that if square root 2 cos x is equal to cos y plus cos cube y and square root 2 sin x is equal to sin y minus sin cube y, we are required to find the value of sin of x minus y. Okay, so we are given two equations. The first one is root 2 cos x is equal to cos y plus cos cube y. Okay, so on simplifying this, we get cos root 2 cos x equal to cos y. Taking cos y common here, you can write 1 plus cos square y, right? Now, this cos square y can be further changed to 1 plus 1 minus sin square y, right? So, this now becomes root 2 cos x is equal to cos y times 2 minus sin square y, right? So, on opening the bracket, this becomes 2 cos y minus sin square y times cos y. Okay, this is from the first relation. All right, let us give this as equation 1. Again, the other relation is root 2 sin x is equal to sin y minus sin cube y. So here, if we take sin y common, this becomes sin y times 1 minus sin square y, right? Now 1 minus sin square y is nothing but cos square y, so this becomes sin y times cos square y. All right, let us give this as equation 2. Okay, now we are required to find this value sin of x minus y. Okay, now sin of x minus y, this is given by sin x cos y minus cos x sin y, right? Now from equation 2 here, okay, from equation 2, sin x can be written as 1 upon root 2. This root 2 is coming in the denominator of the RHS of equation 2, right? Sin x can be written as 1 upon root 2 times sin y cos square y. Okay, this is just sin x times cos y. Okay, minus, similarly cos x can be written as 1 upon root 2 times, I am using this original equation, not this equation 1. Okay, I am substituting this equation. Cos x becomes 1 upon root 2 times cos y plus cos cube y. Okay, cos y plus cos cube y. Okay, and this entire thing is multiplied with sin y. Okay, so on opening this bracket, this becomes 1 upon root 2 times sin y cos cube y minus 1 upon root 2 times sin y cos y minus 1 upon root 2 times sin y cos cube y. Okay, so we see that these two terms cancel each other. Okay, so we are left with minus 1 upon root 2 times sin y cos y. Okay, let this equation be equation 3. Okay, so now let us square and add equation 1 and 2 and see what we can get. Okay, so squaring and adding equation 1 and equation 2. Equation 1 was root 2 cos x in the LHS, right? So this becomes root 2 cos x whole square, and the LHS of equation 2 was root 2 sin x, right? Root 2 sin x whole square is equal to, in the RHS of equation 1, this was 2 cos y minus 2 cos y minus sin square y cos y whole square. And in equation 2, the RHS is sin y cos square y plus sin y cos square y whole square. Okay, so on squaring and adding, this LHS becomes 2 cos square x plus 2 sin square x. So we can take 2 common and this will become 2 times cos square x plus sin square x, right? So this just becomes 2 in the left hand side. In the right hand side, on squaring this a minus b whole square, this becomes 4 cos square y minus 2 times 2 cos y, so it will become 4 cos y times sin square y cos y plus this square b square, this will become sin 4 cos square y plus, on squaring this term, this becomes sin square y cos to the power 4y. Okay, so this gives us 2 is equal to 4 cos square y minus 4 sin square y cos square y, and from the last two terms we can take sin square y cos square y common, and we have a sin square plus cos square. Okay, sin square y plus cos square y, it was sin to the power 4 cos square y, and then the second term is sin square y cos to the power 4y. Okay, so now this becomes 4 cos square y minus, this becomes 4 sin square y cos square y plus sin square y, and this term becomes 1, right? So sin square y plus cos square y, sorry, sin square y cos square y, and this can be further changed to 4 cos square y minus 3, this is 4 minus 1, right? So minus 3 sin square y cos square y. Okay, so let us now change this equation in terms of only cos square. Okay, in equation 1, okay, so this now becomes 4 cos square y minus 3 times 1 minus cos square y times cos square y. Okay, so this becomes 4 cos square y minus 3 cos square y, and this minus 3 times minus, this becomes plus 3 cos to the power 4y. Okay, so if I take all the terms to the right hand side, this becomes 3 cos to the power 4y plus cos square y minus 2 is equal to 0. Okay, so this is a quadratic equation in cos square y. So this can be factorized into, this is product is minus 6, right? So this can be written as plus 3 minus 2. So this becomes cos square y plus 1 times 3 cos square y minus 2, right? We have 3 cos to the power 4y minus 2, and this is plus 3, so plus 1 and then minus 2. Okay, so from here we get either cos square y is equal to minus 1. So this is a square term, right? So a square term cos square y, the maximum value is 1 and the minimum value is 0, right? It cannot be negative. So this is not possible, right? So we have cos square y equal to 2 upon 3. So from this value, from this second factor, we get sin square y is equal to 1 minus cos square y, right? So this becomes 1 minus 2 upon 3. So this is 1 upon 3. Okay. So these are the two values we required, because in equation 3 we have sin x minus y in terms of sin y and cos y. Okay. So we already have sin square y and cos square y. So from equation 3 we had sin x minus y, right? Sin x minus y. So if we square both sides of equation 3, we get sin square x minus y is equal to minus 1 upon root 2 sin y cos y whole square. So this becomes half times sin square y times cos square y. Okay, so it's almost finished now. Sin square y, this is nothing but 1 upon 3. Similarly, cos square y, this is nothing but 2 upon 3, right? So the final answer, this 2 and this 2 cancel each other, so we are left with 1 upon 9, right? So this was square of sin x minus y, right? This was sin square x minus y. We were required to find the value of sin of x minus y. So this is nothing but the square root of 1 upon 9, so which is plus minus 1 upon 3. Okay, so this is your required final answer. Okay, the value of sin of x minus y. Okay, this was a bit complicated in the computation part. Okay, you need to do the squaring and adding, but other than that there is not many tricky steps required here. Okay, this is a very like a bit lengthy but actually very simple question. Okay, so this is the answer. If you know any alternative or shorter methods, okay, you can highlight in the comments also. Okay, or if you think there is any mistake in any of my steps here, you can highlight in the comments. Okay, otherwise this is finished and this is the required answer. Okay, thank you.